Okay, so this is a problem from homework from 12.3, I believe. Somebody asked this question via the Ask My Instructor site. And yeah, so this problem is developed on page 711, I believe, on the book. It's between 710 and 711. It's a more general case where there's they call it economic lot size and the price of how much it costs to storage a product or produce a product are taken care of, and there's an optimal number of batches to produce in order to minimize the storage place in the warehouse. So it's a very interesting problem. The ones in the homework is a little bit more simplified because we're not doing about the intervention of the production. Just as Lodge Hospital has an under demand for 60,000 booklets, so there's going to be every year they're thinking that this is the number they're going to sell. Okay, on healthy eating, it costs 55 cents to store one booklet for a year. So this is a little bit tricky to how they're going to do this for a year, but we'll talk about it in a minute. And it costs $70 to place an order for a new batch of booklets. Find the optimal number of copies per order. So now something to realize a little bit is that although up here it's saying everything in terms of it costs this amount of number of booklets, it costs 55 cents to store one booklet. Down here it says find the optimal number of copies per year. Okay, so the problem that we have to come up with is that the function I'm going to create is going to be the cost function. The cost, but I'm not going to work about the number of booklets. I'm going to work it out by n. I'm going to call n my variable. Is going to be the number of batches, the number of orders I'm going to do, because that's how I can order this. Number of orders in a year for books. Okay, so that means because it costs $70 to place an order, right? This is something that's important. So I can do that by saying the costs, if you have n orders, is going to be, well, $70 per order. So 70 times n, that's the easy part, right? Now the problem is, how many orders are you doing per, how many books per order? Well, you don't really know. You know you're going to have a total of 60,000 in a year. So that divided by the number of orders in a year, that would be how much each order is, right? That's how much each order is going to have. Okay. Now, how much are you going to pay per? So this is about each order, and you're going to pay 55 cents for those, right? Now, it's a bit complicated. If we think that this is the amount of money you pay if the books were stored for the entire year. Now, they're not stored for the entire year. There are several ways to do this. The precise way would have been the first batch gets stored for a longer amount of time, the last batch for a smaller amount of time. So you multiply that, each fraction of the time, times 0.55. And there's a way to do that. But if you read the book, somewhere in the hidden of that it says it's customary to think about half of the year. They have it a little bit different than what I'm writing here, but they put it to there, saying, I think they put it backwards. They say the average of, they want to have the supply demanded half of it. So you want to have 30,000 stored, which is the same as if you divide the 60,000 divided by 2 and then 55 by n. So this is the way I think about it. So this is the amount, this number right here is the amount of books you're going to order each time you put an order. And this is the cost that you're going to pay for having those books. You're not going to have them all year, so some of them you're paying for the entire year, some of them you're paying for half a year, some of them you're paying less than that. So on average you pay 55 cents divided by 2. Yeah, so that's the average you pay for a year. So it's a little bit simplified version of it, but this is the way the book works it out. So this is the function. The function that you would need to find a minimum is 70n multiplied by 60,000 times 0.55 and divided by 2. And this would have to be 16,500 if I believe that, right? Well, over it. Okay, so this is a function you're trying to minimize, find the optimum. So what do? It's calculus, so we're trying to find out a minimum, so find the derivative. So this is just a 70. The hard part is to come up with this function. Once you have it, it's just the same as usual. It's n to negative 1, it becomes n to negative 2, so negative times 16,500 over n squared, right? That's the derivative of this function. So now all I need to do now is find critical points, put it equal to 0. So let's set c prime of n equal to 0 and solve it. So I have, I can do it like 16,500 divided by n squared. Turns out to be 70, right? Once you move it around. So I'm going to go over here so we have everything in the same place. So that means that in 70, n squared turns out to be 16,500. So n squared is 16,500 divided by 70. So n is the square root of that. And this turns out to be close to 15.35. Now that's the number of orders, right? This is the number of orders I'm going to select. So let me put this. I was trying to say this is this. So the question says find the number of copies per order. So now I need to just convert that to number of copies. So if you have 60,000 in a year and you're putting about 15, it says to round, so I'm rounding it to 15, so it's about 4,000. And that's the answer that the book wanted for this problem. So again, it's a little bit tricky. The setup is what makes this problem a little bit confusing. The setup is how do you come up with this function, right? This is a key point of it. So 70n, that part is clear, I hope. It comes from this, right? $70 in order for a new batch of booklets. Then each batch of books that you're going to order, since you want 60,000 per year, you're dividing that by n. N is the number of batches, the number of orders you're going to put in a year. So this is the number of books that come in each order. And for each book that comes there, you're going to pay 55 cents per year for storing them. But you're going to assume that some of those books are stored for the whole year, some of them for half of a year, some of them for a third of a year, some of them for 3/4 of the year. So on average, to store each one for a half a year. So that makes things simple, and then to be the simple function, derivative of that, and we got it. Okay. Now the book, read page 711. There's a formula at the very end already solved for this for put X, K, M, and A's. And if you just put into the formula, you get the answer if you know what the K, the M, and the A is. But I did it again by steps, so you don't have to memorize the formula, and it works out. Okay, I hope this makes sense, and keep asking questions. I'll keep posting answers, or asking questions, and I'll keep explaining.